Hello, welcome back. So today you're going to handle a normalized vector, and another name for normalized vector is vector of unit length. So this vector looks like this. It means that if we have a vector u and this vector u takes this form, then is equals to 1, then we say that u is a normalized vector or a vector of unit length. So we get a normalized vector. For example, you can be given a vector and this vector v is not normalized, so you're saying that it's u, you multiply by its length. So this is how to normalize a vector and make it to be of unit length. So anytime you divide a vector by its length, that vector becomes a unit vector or a normalized vector. So you're using an exercise. Show that we have to prove that is a normalized vector so we have to prove that this is a normalized vector. So the first thing, a normalized vector means that its length or norm is 1. So we are going to find the norm of u over, and if we find the norm, it's the same as raised power a half. This is by the definition of the norm. So we have 1 over norm of u c raised power a half, and now we can 1 over norm is, as scarlet goes out, 1 over norm, but now it's squared. We are left with norm of u raised power half, but now everything here is raised power a half. So this gives us 1 over norm of u raised power a half. This is the same as 1 over norm of u. This definition here is the definition of norm, and we get 1. So that shows that it's a normalized vector, or it's of unit length 1. And then example number 2, we have for the vector. So you have been given 2 vectors, so we want to find some two or three things about that vector. So we are told that so we have vectors. So for vectors 2, 3, 2, negative 1, and we have another vector 2, 2, 3. These vectors are in R3. We are supposed to find number 1, the norm of the vector, and number 2, normalize the vector. So the norm of a vector, we have defined it as So our solution, our norm of our vector is defined as like the inner product of u raised to power a half. So if we have to get the norms of the vectors, it means we get the norm of a, u, and the norm of v. So we are assuming that our first vector here is u and our second vector here is v. So you're saying the norm of 3, 2, -1. You can use any letter you want. So this is the same as 3, 2, -1. We have 3, 2, -1 raised to power a half. So that is a half is the square root. We have 1, 9 plus 4 plus 1. Norm is basically more like the magnitude, but now in linear algebra we don't use terms like magnitude. Instead we use the term norm. So this is basically the magnitude. That's the norm of u. We have the norm of v. Our vector v was 2, 2, 3. So the norm of v is 2, 2, 3. So in vector analysis, you just get the square and then get the square root, but here in linear algebra we write it like this, and then so we are going to get raised to power a half, which is just the square root plus 4 plus 9, and now that is root 17. And now we are told to normalize the vector. So normalizing the vector is quite easy. We have already said that if you want to normalize a vector, you divide it by its norm. So our normalized vector will be, so we have 3 over root 14, 2 over root 14, -1 over root 14, and the other normalized vector will be 2 over root 17, 2 over root 17, and 3 over root 17. So that is how you're getting them, and you remember that it is in that said normed Euclidean inner product space, meaning they have not defined another space that you're supposed to use. And so we are going to the next. We have another simple example. In that example, so we have example 3. So we have an inner product FG. So it's defined on the P2 space. So we are given that the polynomial f of t is t plus 2, and the polynomial g of t is t squared minus 2t minus 3. Now we are required to find the inner product of f and g, and then you go ahead and find the norm of f. So here we have 2 steps. So our first is to get the inner product of fg, but now they have already defined the inner product to be an integral. So this means it's an integral of ft gt from 1, 0. So f of t is t plus 2, and this other one is t squared minus 2t minus 3 dt. So from integration it's quite simple. You just expand, and then after expanding you integrate. and this is a definite integral, so I'm going to have t into t squared minus 2t minus 3 plus 2 into t squared minus 2t minus 3 dt. And so we expand. This is t cubed minus 2t squared minus 3t plus 2t squared minus 4t minus 6 dt. So if you collect the like terms, you realize 2t squared, that one will go to 0. So you will be left with the integral from 0 to 1. You have t cubed minus 7t minus 6 dt. If you integrate, you will get t to the power 4 over 4 minus 7t squared over 2 minus 6t from 1 to 0, and that gives you 1 over 4 minus 7 over 2 minus 6, which gives you negative 37 over 4. Now we want the norm. The norm of f is quite interesting. It's the inner product of this integral ft dt, and now everything is raised to power a half. So this is the integral from 0 to 1. F of t is t plus 2 squared dt. That is the integral. Don't forget here, everything is raised to power a half. That's integral from 0 to 1, t squared plus 4t plus 4 dt. So this is t cubed over 3 plus 2t squared plus 4t. Now everything here, I forgot, is raised to power a half. Even this one here is raised to power a half, so yeah, making that substitution. And that becomes a third plus 2 plus 4 minus 0. This is raised to power a half, so this is just 19 over 3. But now this 19 over 3 is raised to power a half, so this is basically the square root of 19 over 3. Thank you for joining us. Kindly join us on the next as we discuss more of the distance. Bye. See you in the next.